What if everything you thought you knew about space was just scratching the surface? Picture this: the sun, that golden orb we see every day, might not be the color you think it is. Or imagine a planet where a single day is longer than an entire year. These kinds of jaw-dropping revelations aren't just random trivia, they're the realities of the cosmos that school textbooks forgot to mention. In this video, we're diving into 25 astonishing facts about space that will completely rewrite what you think you know about our universe. From rogue planets drifting alone in the vastness to mysterious regions pulling entire galaxies toward them, what you're about to discover will leave you questioning everything. So buckle up, because the greatest mysteries of space are about to unfold, and trust me, you won't want to miss a single one. Now turning to the first astonishing fact, the sun's real color might surprise you. Contrary to what we were taught in school, the sun is not yellow. In fact, it is actually white. So why does it appear yellow when we look up from Earth? The answer lies in a fascinating phenomenon called atmospheric scattering. As sunlight travels through the Earth's atmosphere, the shorter blue wavelengths are scattered in all directions. This leaves behind the longer wavelengths, such as yellow and red, which dominate what we perceive. During sunrise and sunset, this effect becomes even more dramatic, giving us those breathtaking orange and red hues. But in the vacuum of space, without an atmosphere to scatter light, the sun reveals its true nature, a brilliant, pure white star. It's a simple yet profound truth that completely changes how we see the heart of our solar system. Moving forward, get ready for an even stranger planetary twist that defies logic. Now turning to the next extraordinary fact, a day on Venus is longer than its year. Yes, you heard that right. Venus takes 177 Earth days to complete just one rotation on its axis, which makes its day unimaginably long. Meanwhile, its orbit around the Sun takes only about 225 Earth days. This means that within one Venusian year, the planet experiences less than 2 full days. So, why does this bizarre phenomenon happen? The culprit lies in Venus's incredibly slow rotational speed. Scientists believe that this sluggish spin might be the result of immense gravitational interactions during the planet's formation, possibly involving collisions with other celestial bodies. Additionally, Venus rotates in the opposite direction to most planets in the solar system, known as retrograde rotation. If you were standing on Venus's surface, you would see the sun rise in the west and set in the east, the opposite of what we experience on Earth. This strange behavior sets Venus apart, defying the natural order we often expect in planetary systems. But hold on, because next we'll dive into a mind-bending concept that challenges everything we know about planets themselves. Moving forward, let's explore a phenomenon that defies our traditional understanding of planetary systems: rogue planets. Unlike the planets you are familiar with, which orbit stars in harmonious solar systems, rogue planets wander the galaxy completely untethered to any star. These cosmic wanderers roam through the vast darkness of space, lonely and detached. But how do scientists even detect planets that don't orbit a star? It's a daunting challenge, as these planets emit no light of their own and are not illuminated by the glow of a nearby star. Researchers often rely on a technique called gravitational microlensing. This occurs when the rogue planet's gravitational field bends and magnifies the light from a distant star as it passes in front of it, creating a brief but telltale signal. Detecting rogue planets has expanded our understanding of how planetary systems form and evolve. For example, some of these planets might have been ejected from their original star systems due to powerful gravitational interactions or collisions. Others might have formed entirely on their own, outside the realm of a star's influence. These wandering worlds challenge the long-standing idea that planets and stars are intrinsically connected. Could rogue planets even harbor life despite their isolation? Some scientists speculate that under the right conditions, such as a molten core creating geothermal heat, life might still persist on these cosmic outcasts. The existence of rogue planets reminds us that the universe is far more complex and unpredictable than we can imagine. And speaking of mind-bending space phenomena, next, we'll journey into one of the most enigmatic voids in the universe, a place so vast and empty it has left scientists scratching their heads in wonder. Now turning to the Boötes Void, a region of space so immense and eerily empty that it has baffled astronomers for decades. Located roughly 700 million light-years away, this cosmic desert stretches across an astonishing 250 million light-years in diameter, making it one of the largest known voids in the universe. To put that into perspective, if the Milky Way galaxy were placed in the center of this void, the nearest galaxy would be around 300 million light-years away. The Boötes Void contains far fewer galaxies than one would expect for such a vast section of space, with only a handful dotted across its expanse. This profound emptiness raises a puzzling question: how could such a colossal void have formed? Some scientists suggest it may be the result of galaxies merging and clumping together over billions of years, leaving behind an area devoid of significant matter. Others propose that it could be a natural feature of the cosmic web, the vast network of filaments and voids that make up the large-scale structure of the universe. However, this explanation doesn't fully account for its extraordinary size and emptiness. Intriguingly, some theories even entertain the possibility of unknown cosmic forces or phenomena at play, hinting at gaps in our understanding of the physics shaping the universe. The Boötes Void serves as a stark reminder of how much we've yet to uncover about the cosmos and its formation. With mysteries like this still unresolved, the universe continues to challenge our perceptions and stir our curiosity. As we venture further into the unknown, let's shift our focus to another enigmatic force in the universe, a mysterious region that is pulling galaxies, including our own Milky Way, toward it with incredible speed. Now turning to the Great Attractor, a cosmic enigma that exerts an immense gravitational pull on galaxies, including our very own Milky Way. Situated around 200 million light-years away in the direction of the Centaurus constellation, the Great Attractor is part of a galaxy cluster known as the Laniakea supercluster, which houses tens of thousands of galaxies. But what exactly is this mysterious force? Unlike a black hole, the Great Attractor isn't a single point of concentrated gravity swallowing everything around it. Instead, it is thought to be a dense region of galaxies, gas, and dark matter, collectively creating a gravitational pull so powerful that it draws entire galactic clusters toward it at speeds of over 1 million miles per hour. The true nature of the Great Attractor remains elusive, largely because our view of it is obstructed by the Milky Way's densely packed galactic plane, a region referred to as the zone of avoidance. This obscured position makes direct observation incredibly challenging. However, through indirect methods like mapping the velocities and trajectories of galaxies, scientists have been able to estimate its location and influence. One leading theory suggests that the Great Attractor is part of an even larger structure called the Shapley supercluster, which could be amplifying its gravitational pull. Some researchers believe that dark matter, the mysterious substance composing a significant portion of the universe's mass, plays a fundamental role in this phenomenon. As dark matter interacts only through gravity and not light, it adds to the unseen mass, making the Great Attractor even more puzzling. The Great Attractor intrigues astronomers because it's a reminder of how much we still don't know about the underlying forces shaping the cosmos. Its pull not only tugs at galaxies but also at our curiosity, urging us to uncover the secrets of this gravitational mystery. Now, as we continue to explore the depths of space, let's dive into the dazzling world of diamond planets, celestial bodies that might quite literally shine brighter than anything we can imagine. Now turning to the dazzling concept of diamond planets, imagine a world where the very ground beneath your feet could sparkle with gemstone brilliance. One such celestial jewel is the exoplanet known as 55 Cancri e, located around 40 light-years away in the constellation of Cancer. This extraordinary world is over twice the size of Earth and has a surface temperature reaching nearly 4,800 degrees Fahrenheit. But what makes it truly fascinating is its potential composition. Scientists believe that 55 Cancri may have a core rich in carbon, which, under the immense pressure and heat of its environment, could form vast quantities of crystallized carbon, better known as diamond. This idea stems from the planet's unique characteristics and its close proximity to its host star, which contribute to its extreme conditions. The discovery of diamond planets like 55 Cancri challenges our understanding of planetary formation. Unlike Earth, which is primarily made up of silicates and iron, such diamond-rich worlds likely formed in stellar nurseries with an abundance of carbon. These environments allowed planets to coalesce under conditions where carbon dominated, creating compositions unlike anything seen in our solar system. Beyond their scientific intrigue, diamond planets also spark the imagination, inviting questions about their potential beauty and even their economic implications. Of course, harvesting diamonds from these far-off worlds remains firmly in the realm of science fiction, but their existence expands the boundaries of what we thought was possible in the universe. Studying these extraordinary planets not only helps us understand the diversity of planetary systems, but also provides insights into the varying conditions that can give rise to such exotic worlds. The discovery of diamond planets is a testament to the endless marvels of space, showing us that the cosmos truly holds treasures beyond our wildest dreams. As we marvel at the brilliance of these cosmic gems, let us now journey into the shadows of the universe to uncover the enigma of the cold spot, a mysterious anomaly that continues to baffle scientists. Now turning to the curious phenomenon known as the cosmic microwave background cold spot, we step into one of the most puzzling enigmas of the universe. The cold spot is a region in the cosmic microwave background radiation, a faint glow left over from the Big Bang that is significantly cooler than its surroundings. This anomaly spans about 1 billion light-years across and has perplexed scientists since its discovery. The existence of such a large, cold region challenges our understanding of the universe's supposed uniformity. One leading theory proposes that the cold spot could be caused by a supervoid, an immense region of space containing far fewer galaxies, stars, and matter than usual. This lack of material could make the area appear colder because light traveling through it loses energy, a process called the integrated Sachs-Wolf effect. However, even this explanation struggles to fully account for the size and nature of the cold spot, leaving room for other, more speculative theories. Some scientists suggest that the cold spot might be evidence of something even more profound, a collision between our universe and another universe in a multiverse scenario. Imagine if the multiverse exists, our universe could have grazed another, leaving an imprint on the cosmic microwave background. While this idea is still highly theoretical and lacks direct evidence, it opens the door to fascinating possibilities about the nature of reality itself. The cold spot invites us to confront questions that push the boundaries of modern cosmology, reminding us of how much there is still to learn about the universe's origins and structure. As we explore this mysterious void, it becomes clear that even the tiniest temperature anomalies can hold clues to the grandest cosmic mysteries. With that, let us move from the shadows of the cold spot to investigate an entirely different curiosity: the unusual smells of space as reported by astronauts. Now turning to a phenomenon that's both unexpected and surprisingly relatable, let's discuss the peculiar smells of space as reported by astronauts. While the vacuum of space itself lacks air to carry smells, astronauts have described a unique scent that clings to their suits and equipment after spacewalks. They often compare it to the aroma of burnt steak, seared meat, or even welding fumes. This intriguing detail, shared by individuals who have ventured beyond Earth's atmosphere, adds a tactile dimension to our understanding of space. But what could be causing this unusual smell? Scientists suggest it's likely a result of high-energy particles in space interacting with the materials in spacecraft or spacesuits, creating a chemical reaction that leaves behind these distinctive odors. Another possibility is the presence of polycyclic aromatic hydrocarbons, complex organic molecules formed by stars which are thought to emit a similar scent. These molecules are incredibly common in space and may account for the burnt or smoky smell astronauts describe. Whatever the cause, the idea that space has a smell serves as yet another reminder of just how exotic and unique the environment beyond our planet truly is. This small, almost sensory detail sparks curiosity about the ways humans experience the cosmos on a personal level, bridging the gap between the vastness of the universe and the intimate human perspective of those who explore it. With that said, let us shift from the sensory experiences of astronauts to another remarkable revelation, the discovery of water in space in quantities far vaster than we could ever imagine. Moving forward, let us unravel an astonishing truth. Water in space exists on an unimaginable scale, far beyond the confines of planets like Earth. While we often associate water with our oceans, rivers, and lakes, the cosmos has revealed its own colossal reservoirs. One of the most mind-boggling discoveries comes from a quasar known as APM 0827, 9 + 5255, located an unimaginable distance from Earth. This quasar harbors a giant cloud of water vapor, estimated to hold around 140 trillion times the amount of water found in all the oceans on our planet combined. This discovery is not only staggering in terms of scale, but also in its implications for how water is distributed across the universe. Quasars are incredibly powerful and luminous objects, driven by massive black holes at their centers, which release immense amounts of energy as they consume surrounding material. The water cloud surrounding this quasar is tied to its extreme environment, existing under conditions vastly different from those we experience here on Earth. Measuring the water content and other materials in such regions allows astronomers to better understand the early stages of galaxy formation and the behavior of matter in some of the universe's most extreme environments. The presence of water in such abundance also raises profound questions about the universality of this life-essential molecule and what it might mean for the potential habitability of other regions in the cosmos. This massive water cloud serves as a poignant reminder that even in the most distant and energetic corners of the universe, the building blocks of life seem to persist. As we marvel at this cosmic deluge, let us turn next to one of the most mysterious entities in the universe, the phenomenon of black holes and the surprising discovery that they are far from eternal. Now turning to one of the most fascinating revelations of modern astrophysics, let us delve into the nature of black holes and the astonishing theory that they are not the eternal cosmic vacuum cleaners we once imagined. Stephen Hawking, one of the most brilliant minds in theoretical physics, proposed a groundbreaking concept known as Hawking radiation. This theory suggests that black holes, despite their immense gravitational pull, slowly lose mass over time by emitting tiny amounts of thermal radiation. Here is how it works. Around the boundary of a black hole known as the event horizon, pairs of particles and antiparticles are constantly being created due to quantum fluctuations. Usually, these pairs would annihilate each other instantly, but near a black hole, the immense gravitational energy can separate them. One particle falls into the black hole, while the other escapes into space, effectively robbing the black hole of a tiny fraction of its mass in the process. Over an incomprehensibly long time, this steady loss of mass means that black holes will eventually shrink and, in their final moments, explode in a burst of energy as they completely evaporate. This concept has profound implications for our understanding of the universe. It challenges the long-held notion that black holes are eternal and unchanging, suggesting instead that even these colossal objects are subject to the passage of time. Moreover, the study of Hawking radiation bridges the worlds of quantum mechanics and general relativity, two pillars of modern physics that often seem incompatible. By exploring how black holes emit radiation, scientists hope to uncover deeper truths about the nature of time, space, and the fundamental laws that govern the cosmos. This revolutionary idea means that black holes, once considered the ultimate endpoints of matter and energy, are instead dynamic entities with lifespans of their own. And as we ponder their inevitable demise, it opens up new questions about the ultimate fate of the universe itself. As black holes slowly fade into nothingness over trillions of years, what might this mean for the broader cosmic landscape? With these mind-expanding insights, let us journey next into the phenomenon of dark flow, an enigmatic motion of galaxy clusters that defies the known rules of universal expansion. Moving forward, we encounter an extraordinary cosmic mystery that continues to baffle astronomers, the phenomenon known as dark flow. In the vast expanse of the universe, where galaxies are expected to drift apart due to the constant expansion of space, certain galaxy clusters have been observed moving in one specific direction at astonishing speeds. This behavior defies our understanding of universal expansion and raises compelling questions about what lies beyond the observable cosmos. The motion was first detected by analyzing data from the cosmic microwave background, which is the faint glow left over from the Big Bang. Scientists noticed that these galaxy clusters were not just passively drifting, but instead appeared to be pulled toward an unknown region of space. Theories about this puzzling movement range from the influence of massive structures beyond the observable universe, sometimes called Great Attractors, to more speculative possibilities like the gravitational pull of other universes if the multiverse theory holds true. What makes dark flow so captivating is that it hints at forces or entities existing in regions of space we cannot directly observe, pushing the boundaries of what we thought we knew about the universe. While the idea of unseen forces influencing galaxy clusters challenges existing models of cosmology, it also opens up thrilling opportunities to refine and expand our understanding of the cosmos. Could dark flow be a clue to something even more profound about the structure of space and time? For now, it remains one of the most enigmatic riddles of modern astrophysics. And speaking of enigmas, let us now venture into the astonishing density of neutron stars, where a single sugar cube's worth of material would weigh billions of tons on Earth. Now turning to the astonishing density of neutron stars, we find ourselves face to face with one of the most extreme and mind-bending phenomena in the universe. Imagine holding something no bigger than a sugar cube, yet that tiny piece would weigh billions of tons here on Earth. To comprehend this, we need to explore the extraordinary physics at play. Neutron stars are the remnants of massive stars that ended their lives in supernova explosions. During this process, the star's core collapses under gravity to such an extent that protons and electrons combine to form neutrons, packing matter into an incredibly small volume. The result is a celestial object so dense that just a teaspoon of its material could outweigh entire mountains. To put it in perspective, the gravitational force on the surface of a neutron star is so immense that anything falling onto it would be accelerated to incredible speeds, releasing more energy than is produced in the largest nuclear explosions on Earth. This extreme density arises because the matter inside a neutron star exists in a state called neutron degeneracy. This is where quantum mechanics comes into play, as the neutrons are squeezed so tightly that their quantum properties prevent them from collapsing further. It is a stark reminder of how the laws of physics operate differently under such extreme conditions. Neutron stars push the boundaries of what is physically possible, offering scientists a unique natural laboratory to study matter at densities never achievable on Earth. They challenge our understanding of atomic interactions and give us glimpses into the ultimate limits of matter itself. And speaking of challenges to our understanding, let us now dive into the fascinating fact that Saturn, the majestic planet with its iconic rings, could theoretically float in water due to its remarkably low density. Moving forward, let us turn our attention to Saturn, the stunning gas giant that never fails to capture imaginations with its breathtaking rings. Here is a fact that might surprise you. Saturn is so light, relatively speaking, that it could theoretically float in water. How is that possible? It all comes down to its incredibly low density. Saturn's average density is less than that of water, making it the least dense planet in our solar system. This is largely because Saturn is composed mostly of hydrogen and helium, which are extremely light gases. While this floating scenario is, of course, purely hypothetical since there is no body of water large enough to test it, it paints a vivid picture of just how unique this planet is. But Saturn's wonders go far beyond its density. Its iconic rings, made up of countless icy particles ranging in size from tiny grains to massive chunks, set it apart from every other planet. These rings are not solid but instead consist of billions of particles that orbit Saturn like tiny moons, held in place by the planet's powerful gravitational field. Interestingly, scientists are still debating how these rings formed. Some theories suggest they are remnants of a shattered moon, while others propose they are leftover material from Saturn's formation. And while the rings are undoubtedly stunning, Saturn's atmosphere is equally fascinating. It is a swirling world of storms and winds, with speeds reaching over 1,000 miles per hour near the equator. The planet's upper atmosphere displays a mesmerizing blend of yellow and gold hues caused by the interaction of sunlight with ammonia crystals. Together, Saturn's low density, captivating rings, and dynamic atmosphere make it one of the most fascinating celestial objects to study. As we marvel at Saturn's wonders, let's move on to unravel another incredible truth about the vastness of space: the idea that space is not completely silent after all. Now turning to the intriguing notion of space's silence, let's bust a common misconception: the idea that space is utterly silent. While it is true that sound as we experience it on Earth cannot travel through the vacuum of space since sound waves need a medium like air or water, space itself is anything but quiet in a broader sense. Scientists have discovered that electromagnetic vibrations ripple through the cosmos constantly. These vibrations, which span a wide range of frequencies, cannot be heard by human ears directly. However, with the help of special instruments, these signals can be converted into sound waves, creating what we might call the music of the universe. For instance, the electromagnetic waves emitted by planets, stars, and other celestial phenomena have been translated into eerie hums, whistles, and even deep rumbles. These sounds have been captured from various sources, such as the interactions between solar wind and planetary magnetic fields, or the oscillations of faraway black holes. One particularly fascinating example is the haunting soundscape created by Saturn's magnetosphere. Using data from spacecraft like Voyager and Cassini, scientists have generated audio representations of this planetary symphony. The results are otherworldly, resembling something out of a science fiction movie. This ability to hear space not only challenges the perception of a silent universe, but also gives researchers a new way to study celestial phenomena. Through this auditory lens, we gain a deeper appreciation for the dynamic and vibrant nature of space, a place that is alive with movement and energy. With this newfound understanding of space's hidden sounds, let's move ahead to explore yet another mysterious element of the cosmos: the shape of the universe itself. Moving forward, let's unravel one of the most profound questions in cosmology. What is the shape of the universe? Scientists have long debated whether the universe is flat, spherical, or perhaps something entirely beyond our comprehension. To understand this, they have turned to one of the most significant clues available: the cosmic microwave background. This faint glow of radiation is a remnant from the very early universe, acting like an ancient map that holds the secrets of its geometry. By studying its subtle fluctuations, researchers have found strong evidence suggesting that the universe is flat, meaning it expands outward in a way that does not curve back on itself like a sphere or bend outward like a saddle. But as with anything in space science, the story is not quite that simple. While the flat model fits most observations, some anomalies remain unexplained. For example, certain patterns in the cosmic microwave background hint at possible irregularities that could challenge the flat theory. This has led some scientists to speculate about more complex shapes or even dimensions we cannot yet perceive. Others suggest that the universe might be so vast that it appears flat to us, much like how the curved surface of the Earth seems flat when viewed from a short distance. These ongoing investigations remind us that the shape of the universe is not just a question of geometry, but also a reflection of its past, its contents, and its ultimate destiny. With so much still to learn, the quest to map the universe's true shape continues, offering us yet another glimpse into the incredible complexity of the cosmos. Speaking of complexity, let's now turn our attention to something far smaller but equally fascinating: the mysterious quakes that shake up our closest celestial neighbor, the Moon. Now turning to the moonquakes, a phenomenon that might surprise many. Unlike the earthquakes we experience on Earth, which are caused by moving tectonic plates, moonquakes occur for entirely different reasons. Scientists have discovered that these seismic events on the Moon are primarily the result of its slow cooling process. Over time, as the Moon's core gradually loses heat, its interior contracts, causing its brittle crust to crack and shift, which results in these quakes. Some moonquakes are also linked to gravitational interactions with Earth, as the Moon is constantly being tugged by our planet's immense gravity, creating stress that builds up and eventually releases. Interestingly, moonquakes are not as frequent as earthquakes, but when they do occur, they can be surprisingly powerful. Some of them last much longer than typical earthquakes, sometimes for up to 10 minutes. This is because the Moon lacks the same atmosphere and liquid water that Earth has, which helps to dampen seismic vibrations. These extended tremors on the Moon offer a fascinating glimpse into its geological activity and history. But moonquakes are more than just a scientific curiosity. They have significant implications for future lunar exploration. For instance, understanding where and why these quakes happen is essential for building structures and habitats on the Moon. Future lunar bases will need to be designed to withstand these long-lasting seismic events. Additionally, monitoring moonquakes can help scientists learn more about the Moon's inner composition, providing clues about its evolution over billions of years. As we prepare for humanity's next steps on the Moon, studying these mysterious quakes is yet another reminder of how much there is still to discover about this familiar yet enigmatic celestial neighbor. Moving forward, let us journey far beyond the Moon and dive into the story of the farthest star we have ever detected, a cosmic marvel that stretches the limits of our understanding of distance and time. Moving forward, let us journey to the edges of the observable universe and uncover the story of Earendel, the farthest star ever detected. This extraordinary star is located an astonishing 28 billion light-years away from Earth, a distance so vast it challenges our understanding of space and time. Earendel's light has traveled nearly the entire history of the universe to reach us, offering a rare glimpse into the cosmos as it existed billions of years ago. But how was such a distant star even discovered? The answer lies in a phenomenon known as gravitational lensing. Imagine light from a distant object like Earendel passing near a massive galaxy or a cluster of galaxies on its way to Earth. The intense gravity from that massive object bends and magnifies the light, much like a giant cosmic magnifying glass. This bending of light allowed the Hubble Space Telescope to detect Earendel, a star that would otherwise have been far too faint and distant to observe. Scientists believe Earendel is a massive star, hundreds of thousands of times brighter than our Sun. Studying it provides a unique opportunity to learn about the early universe, including the formation of stars and galaxies during its infancy. The discovery of Earendel is not just a triumph of observational astronomy, it also raises questions about what more lies beyond our current reach. What other cosmic wonders might gravitational lensing help us uncover? As we continue peering deeper into the universe, Earendel serves as a beacon, reminding us of the infinite mysteries waiting to be explored in the vastness of space. With this incredible star leading us further into the unknown, our cosmic journey takes us next to an equally fascinating subject: the phenomenon of hypervelocity stars, celestial objects that defy the gravitational bonds of galaxies and race through space at unimaginable speeds. Now turning to the phenomenon of hypervelocity stars, prepare to be amazed by these celestial speedsters defying the gravitational pull of entire galaxies. Hypervelocity stars are stars that have been ejected from their home galaxies, racing through space at speeds reaching millions of miles per hour. But how does something so massive break free from the immense gravitational grasp of a galaxy? The answer often lies in encounters with black holes. Imagine a binary star system where two stars orbit each other closely. If this system drifts too near to a supermassive black hole at the center of a galaxy, the intense gravity can tear the system apart. One star might be captured by the black hole, while the other is flung away at astonishing speeds, transforming into a hypervelocity star. These stars are rare, but their discovery provides fascinating insights into the dynamics of galaxies and the immense power of black holes. One of the most famous hypervelocity stars is known as He0 4375439. Initially thought to originate from our own galaxy, further studies revealed it traveled from the Large Magellanic Cloud, a neighboring galaxy. This discovery highlights how hypervelocity stars can serve as cosmic messengers, tracing the gravitational landscape and history of their galaxies. Studying them offers clues about black hole interactions, galactic structures, and even the potential existence of undiscovered black holes. The sheer speed of hypervelocity stars might seem like an anomaly, but they remind us of the chaotic and dynamic forces shaping our universe. With every discovery, they challenge our understanding of how galaxies and their components interact, uncovering secrets hidden in plain sight. And as we move from these high-speed marvels, our journey takes us to the icy edges of our own solar system, where the enigmatic Oort cloud awaits with its mysteries about comets and the farthest reaches of the sun's influence. With the next phase of the journey in sight, we venture to the distant outskirts of our own solar system, where a mysterious and hypothetical region known as the Oort cloud resides. This vast expanse, thought to envelop the solar system like a giant shell, is believed to be filled with icy bodies left over from the early formation of the Sun and planets. Stretching far beyond the orbit of Neptune and even the Kuiper belt, the Oort cloud represents the boundary of the Sun's gravitational influence. But what makes this distant region so intriguing? The answer lies in its connection to comets. Many long-period comets, those that take thousands or even millions of years to complete their orbits around the Sun, are thought to originate from this icy reservoir. When a passing star or the gravitational forces of the galaxy disturb the Oort cloud, some of these frozen objects are sent hurtling toward the inner solar system, becoming the brilliant comets we see streaking across the sky. These celestial visitors are like time capsules, preserving ancient material from the solar system's infancy and providing scientists with invaluable clues about its early history. Despite its significance, the Oort cloud remains a theoretical construct, as no direct observations have yet confirmed its existence. However, models of solar system dynamics strongly support its presence, making it a key piece of the cosmic puzzle. The Oort cloud also marks the outermost edge of the Sun's domain, a region where its gravitational pull begins to wane and interstellar space takes over. It raises profound questions about the interactions between our solar system and the galaxy beyond. Could the Oort cloud hold secrets about the sun's past encounters with other stars, or even hint at the presence of rogue planets? As a frontier yet to be explored, it challenges us to rethink the boundaries of our celestial neighborhood. And as we leave this icy realm of speculation, our next stop takes us to the heart of the sun, where quantum physics plays a surprising role in powering the star that sustains life on Earth. Now turning to the very core of our solar system, we arrive at the sun, a powerful life-giving furnace whose energy sustains everything on Earth. But have you ever wondered how the sun manages to generate such immense energy for billions of years? The answer lies in a mind-bending phenomenon from the realm of quantum physics called quantum tunneling. At the sun's core, where temperatures reach millions of degrees, hydrogen nuclei, or protons, are squeezed together under immense pressure. These protons carry a positive charge, and as you might remember from basic physics, two positive charges repel each other. In theory, the conditions in the sun should not be enough for these protons to overcome their natural repulsion and fuse together. Yet they do because of quantum tunneling. Imagine a particle faced with a barrier it cannot climb over, but instead of being stopped, it magically tunnels through to the other side. That is quantum tunneling. In the sun, this allows protons that would otherwise be repelled by each other to come close enough to fuse, initiating the nuclear reaction that produces helium and releases vast amounts of energy. Without quantum tunneling, these reactions simply wouldn't occur, and our sun would be a cold, dark mass of gas rather than the fiery star we know. This process is a perfect example of how the strange and seemingly improbable world of quantum mechanics governs the workings of the universe on an unfathomable scale. It challenges our everyday understanding of how the physical world operates, showing us that even the most fundamental forces of nature follow the laws of physics in extraordinary ways. As scientists study quantum tunneling, they not only uncover the secrets of the sun's energy production, but also gain insights that could transform our understanding of nuclear reactions here on Earth. With this remarkable phenomenon lighting up the heart of our solar system, our journey now takes us to a galaxy unlike any other, a place where isolation and mystery intertwine to reveal the loneliest galaxy in the universe. With the next phase of the journey in sight, let us explore one of the most peculiar and hauntingly mysterious places in the cosmos, NGC 1052 DF2, often referred to as the loneliest galaxy in the universe. Unlike most galaxies, which are rich with dark matter, this faint and ghostly formation appears to lack the very ingredient thought to be essential for galaxy development. Dark matter, an invisible substance that makes up around 85% of the total matter in the universe, is believed to provide the gravitational glue that binds galaxies together. Yet, NGC 1052 DF2 defies this fundamental principle, holding its structure seemingly without this crucial component. Adding to its enigma, this galaxy is almost completely isolated, floating in a quiet corner of the universe with almost no galactic neighbors nearby. For scientists, its bizarre existence raises profound questions. How did a galaxy like this form, and why does it lack dark matter? Some theories suggest it might have been stripped of its dark matter through a series of dramatic cosmic events, such as interactions with other galaxies or massive tidal forces. Others hypothesize that its formation might have been a fluke, offering a rare glimpse into alternative pathways for galaxy evolution. But beyond its lack of dark matter, there is also something poetic about its solitude. In a universe brimming with countless galaxies, each surrounded by clusters of companions, NGC 1052 DF2 exists in near isolation like a cosmic hermit. Its existence challenges our understanding of how galaxies grow and interact, forcing astronomers to rethink long-standing assumptions about the fundamental role of dark matter. By studying this galaxy, scientists hope to not only uncover the secrets of its formation, but also gain deeper insights into the very fabric of our universe. And as we ponder the mysteries of this unusual galaxy, we now set our sights on an entirely different phenomenon, a breathtaking journey into the realm of stars ejected at unimaginable speeds, known as hypervelocity stars. Now turning to a topic that dances on the edge of science and imagination, let us delve into the curious idea of hollow planets. While mainstream science firmly supports the understanding that planets are solid or contain molten cores, the concept of hollow celestial bodies refuses to completely fade into obscurity. This notion suggests that some planets could be vast, empty shells housing internal worlds or even advanced civilizations. Though modern astrophysics has debunked the possibility of such structures, citing overwhelming evidence from gravitational studies, seismic data, and planetary formation theories, the idea persists in the realms of science fiction and speculative thought. Stories of hollow planets often invoke a sense of wonder, painting vivid pictures of hidden realms illuminated by internal suns or populated by alien ecosystems. Some proponents of the theory point to unusual planetary phenomena as potential evidence, though these are readily explained by established science. For example, anomalies in a planet's magnetic field or unexpected surface features are often cited, but these have been attributed to natural processes like volcanic activity or tectonic shifts. The enduring appeal of hollow planets lies largely in their cultural and narrative power. They have served as the backdrop for countless myths, books, and films, where they symbolize the allure of the unknown and the possibility of secret worlds waiting to be discovered. While the scientific consensus leaves little room for such ideas to be factual, their lasting presence in the human imagination reminds us of our innate curiosity and desire to explore beyond the surface of reality. And as we leave this speculative concept behind, our journey continues with a fascinating look at the strange and dramatic phenomenon of white dwarfs that refuse to stay dead, nicknamed zombie stars. Moving forward, let us uncover the eerie and captivating phenomenon of zombie stars, a nickname given to white dwarfs that seemingly come back to life. White dwarfs are the remnants of stars that have burned through their nuclear fuel, leaving behind dense, lifeless cores. But under the right circumstances, these celestial corpses can siphon material from a nearby companion star, reigniting nuclear reactions on their surfaces. This stolen energy allows them to briefly spring back to life, culminating in a spectacular explosion known as a Type 1, a supernova. The term zombie star perfectly encapsulates this process, as these once dead stars appear to rise again in a brilliant final act. This phenomenon not only provides a dramatic spectacle, but also serves as an invaluable tool for astronomers. Type 1, a supernovas are considered standard candles in space, meaning their consistent brightness allows scientists to measure vast cosmic distances and better understand the universe's expansion. The study of zombie stars sheds light on the complex and interconnected lives of stars, revealing how even in death a star's story may not truly end. From these dramatic rebirths, we now turn our gaze to an equally astonishing concept, gravitational time dilation, where time itself bends and stretches under the influence of gravity. Now turning to the fascinating concept of gravitational time dilation, let us unravel how time itself is not a constant but instead bends and stretches under the influence of gravity. This phenomenon, predicted by Albert Einstein's theory of general relativity, reveals that time moves slower in stronger gravitational fields. Imagine standing on a mountain while your friend stands at sea level. Because gravity is slightly weaker at higher altitudes, time would actually pass faster for you than for your friend, although the difference would be immeasurably tiny in this case. On a larger scale, however, the effects become strikingly apparent. Take GPS satellites, for instance. These satellites orbit Earth at high altitudes where gravity is weaker compared to the planet's surface. As a result, time moves slightly faster for the satellites than for clocks on the ground. Engineers must account for this difference to ensure GPS systems provide accurate location data. But the most extreme example of gravitational time dilation occurs near black holes, regions of space with gravity so intense that even light cannot escape. If you were to approach a black hole, time for you would slow down dramatically compared to someone observing you from a safe distance. To the distant observer, it might appear as though you are frozen in time at the edge of the black hole, a phenomenon caused by the immense gravitational pull distorting the fabric of space-time. Gravitational time dilation not only challenges our intuitive understanding of time, but also opens up endless possibilities for exploring the universe's mysteries. With this mind-bending concept in place, let us venture further into the cosmic frontier to uncover the largest known structure in the universe, a supercluster so vast it challenges the very principles of cosmology. Moving forward, we arrive at an awe-inspiring discovery that redefines the scale of the universe: the Hercules Corona Borealis Great Wall. This colossal structure, spanning an unimaginable 10 billion light-years, is a supercluster of galaxies bound together by gravity. To put that into perspective, even at the speed of light, it would take 10 billion years to travel from one end to the other. Such a scale is almost beyond human comprehension, yet it exists, challenging some of the fundamental principles of cosmology. One of those principles is the cosmological principle itself, which assumes that the universe on a large scale is homogeneous and isotropic. In simpler terms, this means the universe should look roughly the same no matter where you observe it from. However, the sheer size of the Hercules Corona Borealis Great Wall disrupts this idea. Its existence suggests that the distribution of matter across the cosmos might not be as uniform as scientists once believed. The discovery of this structure raises profound questions about the formation and evolution of the universe. How could something so massive form in a universe governed by the laws of physics as we understand them? Could this be evidence of anomalies in the way matter has clumped together over billions of years, or does it hint at mechanisms we have yet to uncover? The answers remain elusive, but one thing is clear: the Hercules Corona Borealis Great Wall is a monumental reminder of the universe's vastness and complexity. It pushes the boundaries of what we thought was possible and invites us to rethink our place in the grand cosmic tapestry. As we marvel at this cosmic marvel, let us reflect on just how much there is left to discover about the universe and how such discoveries continue to expand the horizons of human knowledge. Now turning to a closer look at the sun's true colors, let's dive even deeper into how our perception of it is influenced by factors beyond just atmospheric scattering. While the sun is inherently white, appearing yellow from Earth due to the way our atmosphere scatters shorter wavelengths of light, there's another variable that can alter its color: atmospheric pollution. Particles in the air, such as dust, smoke, or even volcanic ash, can shift the sun's hue into shades of orange or red, especially during sunrise and sunset. This happens because these particles scatter light differently, allowing longer wavelengths like red and orange to dominate while shorter wavelengths are absorbed or scattered away. But it's not just pollution. Weather conditions like humidity or even the angle of observation play a role. Imagine standing in a city where smog thickens the air. The sun might appear almost crimson, a stark contrast to its natural white glow in space. These shifts in color don't just affect how we see the sun, but also how we study celestial bodies. For instance, pollution and atmospheric distortions can impact astronomical observations, requiring advanced technology to filter out these effects. Understanding the true colors of stars, including our sun, helps scientists identify their composition, age, and even the types of nuclear reactions happening within them. From Earth, however, our perspective is always tinted, sometimes quite literally, by the layers of atmosphere between us and the cosmos. It's a fascinating reminder that, while we're observing the universe, our vantage point on Earth shapes what we see. This interplay between perception and reality is just one more reason why space exploration continues to expand our understanding of the universe, bypassing the limits of our atmospheric lens. Moving forward, let's examine Venus, where a day stretches out longer than a year. This bizarre characteristic is due to Venus's incredibly slow rotation, taking about 243 Earth days to complete just one spin on its axis, while it takes only 225 Earth days to orbit the Sun. But this is not just a trivia-worthy fact. It has profound consequences for its atmosphere and surface environment. With such a prolonged day-night cycle, the planet endures extreme thermal conditions. The side facing the Sun bakes for months on end, reaching surface temperatures hot enough to melt lead, while the prolonged night doesn't offer much relief, as the thick atmosphere traps heat efficiently, creating an almost uniform oven-like environment across the planet. This slow rotation also contributes to the peculiar behavior of Venus's atmosphere. Winds in the upper atmosphere move at speeds hundreds of times faster than the planet itself rotates, a phenomenon known as superrotation. This leads to a complex interplay of heat distribution and weather patterns, further amplifying the planet's extreme conditions. Exploring Venus's slow rotation not only provides insights into its status as one of the most inhospitable planets, but also challenges our understanding of atmospheric physics and planetary dynamics. As we unravel these mysteries, it highlights how alien and diverse planetary systems can be, reminding us just how unique and precious Earth is in comparison. Now, as the next mystery emerges, let's look at a completely different phenomenon that shakes our understanding of planetary systems, the enigmatic rogue planets. Now turning to one of the most puzzling phenomena in the cosmos, let's explore the enigmatic cold spot. This mysterious region of the universe stands out because it is unusually cooler than the surrounding cosmic microwave background radiation, the faint afterglow of the Big Bang. Discovered through meticulous observations, the cold spot spans an enormous 1 billion light-years, leaving scientists scratching their heads over its origins. What could cause such an odd anomaly in the otherwise uniform temperature of the universe? One prevailing theory suggests it could be the result of a massive supervoid, a colossal region of space with far fewer galaxies, stars, and matter than normal. This supervoid, if it exists, might create the illusion of cooler temperatures by stretching and redshifting the light passing through it over billions of years. But here's where things get even more intriguing. Alternative cosmological models propose the cold spot might not simply be a natural feature of our universe. It could point to something even more extraordinary. Some experts theorize that this anomaly might be evidence of a collision between our universe and another universe, lending tentative support to the idea of a multiverse. Imagine for a moment our universe brushing against a parallel universe like two soap bubbles gently colliding. Such an event could create disturbances visible in our cosmic map, like the cold spot itself. This idea is still highly speculative, but it fuels debates about the very fabric of reality and whether our universe is just one among countless others. The cold spot challenges the conventional understanding of the cosmos, making it one of the most tantalizing mysteries for scientists to unravel. As we contemplate such possibilities, it reminds us of how little we truly know about the grand tapestry of existence. Moving forward, let us delve into a cosmic phenomenon that fascinates and frightens in equal measure: black holes and their surprising fate of evaporation. Moving forward, let us unravel the surprising and complex fate of black holes' evaporation. Black holes, often imagined as eternal cosmic monsters devouring everything in their path, may not last forever. Thanks to the groundbreaking work of physicist Stephen Hawking, we now know that black holes slowly lose mass over time through what is known as Hawking radiation. This process occurs because quantum mechanics suggests that particle-antiparticle pairs can spontaneously form near the event horizon, the invisible boundary of a black hole. While one particle falls into the black hole, the other escapes, effectively stealing a tiny fraction of the black hole's energy. Over unimaginable spans of time, this gradual loss of mass means that even the largest black holes will eventually shrink, weaken, and finally disappear in a burst of energy. This raises an intriguing question. What would a universe without black holes look like? As these cosmic giants evaporate, they could play an essential role in shaping the universe's ultimate destiny. Without black holes, the universe would lose some of its most extreme gravitational anchors, potentially altering the motion of stars and galaxies. Furthermore, the energy released during a black hole's final moments might contribute to the overall distribution of matter and radiation across space. In the distant future, far beyond the lifespan of any stars, this evaporation could even be one of the last significant events in a fading cosmos. The end of black holes ties into deeper questions about the universe's fate. Will it continue to expand into a cold, empty void, or is there a yet unseen phenomenon waiting to emerge? Hawking radiation not only challenges our understanding of black holes, but also serves as a reminder that even the most powerful entities in space are not eternal. As we bid farewell to these mysterious objects in theory, let us now shift our gaze to a discovery that pushes the boundaries of how far we can see into the universe, the farthest star ever detected. With the next phase of the journey in sight, let us explore the incredible mechanics behind the discovery of the farthest star ever detected, named Earendel. This star's light has traveled an astonishing distance of approximately 28 billion light-years to reach us. But how does such a feat of observation even become possible? The answer lies in a fascinating phenomenon known as gravitational lensing. Picture this: light from a distant galaxy or star is bent and magnified as it passes near a massive object like a galaxy cluster positioned between the light source and us. This effect, predicted by Albert Einstein's theory of general relativity, essentially turns these massive objects into cosmic magnifying glasses. In the case of Earendel, a massive galaxy cluster acted as this lens, amplifying its light to an extraordinary degree and allowing astronomers using the Hubble Space Telescope to detect a star that would otherwise be far too faint to see. This discovery is not just a record-breaking observation. It provides a unique window into the early universe, a time when the first stars and galaxies were beginning to form. By studying Earendel's light, scientists can analyze its composition and gain insights into the types of stars that existed billions of years ago. This helps us piece together the puzzle of how the universe evolved from a dense, hot primordial state into the breathtaking cosmic expanse we see today. Furthermore, such discoveries push the boundaries of what we know about gravitational lensing, helping refine our understanding of dark matter, as these galaxy clusters are rich in this mysterious substance which significantly influences the lensing effect. Each star like Earendel that we find takes us closer to understanding our origins and the processes that shape the cosmos. And as we delve deeper into the mysteries of the universe, let us now turn to the existence of stars that defy our conventional understanding by moving at astonishing speeds, hypervelocity stars. As the next chapter of our cosmic journey begins, let us explore one of the most mind-bending structures in the known universe, the Hercules Corona Borealis Great Wall. This colossal arrangement of galaxies spans an unimaginable distance of approximately 10 billion light-years, making it the largest known structure in the cosmos. To put that into perspective, it is so vast that even light, traveling at its incredible speed, would take 10 billion years just to cross it. But what sets this supercluster apart from others we have discovered? While most galaxy clusters are enormous, they tend to follow a certain scale and distribution that aligns with the cosmological principle. The idea that, on a large scale, the universe is uniform and isotropic. However, the Hercules Corona Borealis Great Wall seems to defy this principle entirely. Its sheer size and scale challenge our understanding of how the universe is organized, suggesting that our current models of cosmic structure formation may be incomplete or require significant revision. Scientists believe that structures of this magnitude should not exist according to the known laws of physics and the rate of universal expansion. So how did this extraordinary cluster form? Theories range from the influence of dark matter, an unseen substance that shapes the universe, to the possibility that this region is a remnant of unique conditions in the early universe when matter and energy were distributed in a less uniform way. Studying the Hercules Corona Borealis Great Wall provides a rare opportunity to test these theories and explore the forces and phenomena that govern the formation of such enormous structures. It also pushes the limits of what we consider possible within the framework of our current understanding of cosmic evolution. These discoveries remind us that the universe is not only vast but also filled with mysteries that continue to challenge and expand the boundaries of human knowledge. And as we marvel at this colossal structure, we are reminded once again of the profound scale of the cosmos and our quest to uncover its secrets. With this in mind, let us now take a step back and reflect on the incredible facts we have explored, each one offering a glimpse into the infinite wonder and complexity of space. As we conclude this journey through the wonders of the universe, let us take a moment to reflect on the incredible facts we have uncovered. From the Sun's true color and Venus's astonishing day-to-year ratio to the enigma of rogue planets, diamond cores of distant worlds, and the mysterious cold spot that might hint at a multiverse, each discovery has revealed just how little we truly know about the cosmos. We have marveled at the mind-bending density of neutron stars, the fleeting nature of black holes as they emit Hawking radiation, and the vast expanse of the Hercules Corona Borealis Great Wall, a structure so immense that it challenges the very principles of cosmology. The mysteries of space, whether hidden in the quiet whispers of moonquakes, the distant light of hypervelocity stars, or the lonely isolation of galaxies like NGC 1052 DF2, continue to push us to reimagine our place in this infinite expanse. These facts, though staggering, are only a tiny fraction of what the universe holds. Every discovery reminds us that our understanding is but a drop in an endless cosmic ocean, sparking questions about what lies beyond the edges of our knowledge. What new phenomena wait to be uncovered? What secrets of existence lie tucked away in the furthest corners of space? The universe invites us to keep exploring, to remain curious, and to never stop asking questions. Which of these facts amazed you the most? Share your thoughts or your own favorite space discoveries in the comments below. And if you enjoy unraveling the mysteries of the cosmos as much as we do, be sure to like this video, subscribe to our channel, and hit the notification bell so you never miss an incredible journey through the stars. The adventure into the universe has only just begun.